today we are talking about some past paper questions, which I found particularly interesting while solving the past papers. So, ABC is an isosceles triangle such that AB is equal to AC, A has coordinates 437, B and C lie on the line with equation 3y is equal to 2x plus 12. Find an equation of the line of symmetry of triangle ABC. Give your answer in the form of px plus qy equals r, where p, q, and r are integers. Show clear algebraic working. Let's go. So the first thing that you must do here is you must draw. And you need to draw in any math problem. The best way for your brain to perceive it is by visualizing it. So let's draw an isosceles triangle. This is our lovely isosceles triangle such that AB is equal to AC. So we know that point A is over here. We know that this is point B and this point C. Let's call those the 3 points. We know that this is an isosceles triangle. This is equal to this. Find an equation of, A has coordinates 437. So 437. Nice. B and C lie on the line with equation 3y is equal to 2x plus 12. Now this is slightly harder to draw. And what we will do is we will just extend the line BC, just like that. And you will say that this has the equation 3y to 2x plus 12. What do we do after having done all of this? Now we need to think slightly. So we need to find the line of symmetry of triangle ABC. Now, obviously, the line of symmetry is this line. Now, you might remember from properties of isosceles triangles that between the line of symmetry of a triangle and its base, there will always be a 90-degree angle. And so this is the idea that we will be massively using in this problem. So, now we know that the equation for the base is 3y is equal to 2x plus 12. So why not find the perpendicular to that equation? So, first, when you're trying to find the perpendicular, you have to bring it into the form of y equals kx plus c. How do we do that? Well, we simply divide everything by 3. So y is equal to 2 over 3x plus 4. Now we have to find the perpendicular. The perpendicular will have a gradient, so this, which multiplies to this gradient to give -1. And now I will just tell you the answer straight away. It's y equals -3 over 2x. Why? Because 2 over 3 times -3 over 2 is equal to -1. And now this equation gives us one specific graph, which is parallel to the graph 3y is equal to 2x plus 12. That is not enough. We need a multitude of graphs, because then we will be finding the equation of this graph over here. So we would just add plus some sort of constant. Let's call it plus k. Now, with this k over here, that gives us every single possible graph that is parallel to 3y is equal to 2x plus 12. Now we need to notice something very important. We need to notice that the graph that we're searching for passes through point 437. Now there will be only one graph parallel to this line that passes through point 437. So what we can do is we can simply substitute 4 into x and 37 into y. So let's do that. 37 is equal to -3 over 2 times 4 plus k. Therefore, 37 is equal to -6 plus k. Therefore, k is equal to 43. Nice. So what does this give us? This gives us the equation of this red line, of the bisector. And the equation of it is just this, but now we know k, so we can simply say that k is equal to 43 over here. There, so this is the equation that we're looking for. But now we will not have gotten all of the 5 marks. And yes, by the way, this question is a 5-mark question. It's pretty big and pretty important. This will not have given us 5 marks. Why? Because give your answer in the form of px plus qy is equal to r. So we need to bring it to that form now. And that will give us the final marks. So how do we do that? First of all, let's carry the negative 3 over 2x to the left. So y plus 3 over 2x is equal to 43. Now we have to multiply it all by 2 because we need integers. I mean, it doesn't specify that we need integers, but we just need something over here that we don't have. So we just go 2y plus 3x is equal to 86. And this is in the form that we need it to be in. So this is in the form px plus qy is equal to r. And this is in fact the correct answer. So this is how you solve questions like this. And there's 2 key points to remember here. And that is first, that the perpendicular to a graph will always have 2 gradients that multiply to be -1. So I'll just write it out in algebra just to make you understand it slightly more. So say if we have the graph y equals mx plus k, and we have the graph y equals bx plus c, and if we say that this is, for example, graph A, this is graph B, and we say that graph A is perpendicular to graph B, then we for sure from that know that m times b is equal to -1. And now, on the contrary, if they are parallel, so if graph A is parallel to graph B, we for sure know that m is equal to b. Okay. Now let's go on to the next past paper question, which I found really interesting. This was the second from last question in a past paper, and it is the following. You can read it. So let's begin solving. Now, a circle center O, so we immediately know that O is the center, has a circumference of 20 pi. Now this is very significant. The moment we're given something, we have to think about why it's given. So circumference of 20 pi. Now what's the formula for the circumference? 2 pi r. So 2 pi r is equal to 20 pi. Nice. So we can just cancel that, cancel that, cancel that, and we get that r is equal to 10. Boom. That's our first great discovery. Q is a point on the circle. All right, why was that given to us? Well, that was given to us so that now we know that OQ is by definition a radius. So we know that OQ is equal to 10. All right, perimeter of the square is proportional to the circumference of the circle, such as the square root A is proportional to pi. That's very significant as well, where A is an integer. Okay, work out the value of A. Nice. So we need to figure out the perimeter of the square. Now this might seem hard, but we already did it, essentially. We know that the diagonal of the square is 10. Now, because this is a square, QP is equal to OP. And using Pythagoras theorem, again, because this is a square, we can immediately say that this is a right angle. Using Pythagoras theorem, we can say that, let's call this A, let's call this B, A squared plus B squared is equal to 100. But we know that A is equal to B, so therefore 2A squared is equal to 100. A squared is equal to 50. Therefore, A is equal to the square root of 50. So this is the square root of 50. And this is square root of 50. Nice. So then, because this is a square, once again, we can just simply say that this is the square root of 50, and this is the square root of 50. So the perimeter of the square is, perimeter square is equal to 4 square roots of 50. Nice. Now we need to know the circumference of the circle, where we are already given that. We're given that the circumference of circle is equal to 20 pi. Okay. Now we have to use one of these last statements. Perimeter of the square is proportionate to the circumference of the circle, like the square root of a is proportionate to pi. So let's go. The square root of a, so the perimeter of the square is 4 square root 50. It's proportionate to 20 pi. And we have to bring it in the form of square root a is proportional to pi. Let's go. Okay, so first of all, we need to divide everything by 20. It's pretty self-explanatory. So 4 square root 50 divided by 20 is proportionate to pi. Nice. Now we get square root 50 divided by 5 proportionate to pi. Okay, now we have to work with surds slightly. So from this we can infer that 5 square root 2, and I'll explain how I got this in a later video that's coming out on surds pretty soon, so stay tuned. 5 square root 2 divided by 5 is proportionate to pi. Therefore, square root 2 is proportionate to pi. Therefore, a is equal to 2. That's it. So now surds are an important topic that I will cover in a video. But yeah, this is probably the only thing that you might have not understood in this video. The rest is pretty self-explanatory. So yeah, thank you for watching. I hope this was useful. Please leave in the comments if you like videos of this format where we look at past paper questions. And yeah, see you next time. Bye.